Assalamualaikum to our lecturer, Madam Sharifah and Madam Nora. We are on our way to one of the leading quantity surveying firms, AHR Juru Ukubahan, located in Taman Melawati. We are here to gather information and data for our selected 4-story building, which is ICC Pudu.
Assalamualaikum. My name is Farish and I'm going to introduce the project used in our study, which is the Integrated Commercial Complex Pudu, which is also known as ICC Pudu. The project is located in Pudu, Kuala Lumpur, and it has 7-story building, and it is a commercial buildings developed by the DBKL, and one of the main purposes is to relocate the market from the TRX area to a new facility which located in ICC Pudu. Next, in the ICC Pudu, it includes Kuala Lumpur Police Headquarters, government office, shops, foods area, and also parking facilities. This makes an ICC Pudu as a mixed-use building which meets the requirement for this assignment. Not only that, the key parties involved in this project is DBKL as a client, and also as developer, and DS Sapakat Sdn Bhd as the main contractor, and the consultants such as architect and quantitative surveyor is ARH Juru Ukus Sdn Bhd. Next, the original contract sum was RM 52 million and the contract period was 80 months, with site possession in August 2014 and completion in November 2016.
So moving on to the format of VQ. The format of VQ plays a very important role in the preparation of tender document. A properly formatted VQ helps contractors clearly understand the scope, requirement, and sequence of work for each building element. At the same time, it allows contractor to estimate costs more accurately, which contribute to smoother project and implementation during the construction stage. In general practice, the BQ is prepared based on standard method of measurement, commonly known as SMM2, together with other approved standard. This standard ensure that all building elements such as concrete work, reinforcement, and formwork are clearly described, measured using the correct units, and properly classified. For example, in this project, elements like upper floor slab and roof slab are broken down into items such as concrete work measured in cubic meters, reinforcement measured in kilograms, and formwork measured in square meters. SMM2 provide detailed guidance for each work item. It specifies the description, classification, measurement of rule, and level of detail required. This helps avoid ambiguity and ensure consistency between the tender document and site execution. However, for this project, the BQ format to refer this SMM1 instead of SMM2, making it less detailed. This situation occurs because the project is based on an older standard and also reflect the difference between the academic learning environment and the real working environment. In academic setting, students are required to strictly follow SMM2 rules to develop strong fundamentals in preparing complete and accurate BQ. However, the professional practice quantity surveyor often face time constraint and work pressure, especially when handling large or complex project with multiple elements. As a result, the BQ may be prepared using general measurement principle rather than fully detailed requirement, as long as the description remain clear and functional. In conclusion, this highlights the gap between theory and practice in BQ preparation. To address time constraint while maintaining quality, the use of modern software application alongside manual adjustment is recommended.
Hello and Assalamualaikum. My name is Sri and I will explain about bit of quantities and its supervision. So before we start, I will explain briefly about the BQ. The BQ referred to SMM1 because it's an old project started on 2014. On the BQ, we can see it have two sections on the quantity and amount, section 1 and section 2. Reason behind this is because there are market behind the site, so they want to move and operate with immediate effect. They just built up to 2 floors under ARH. and the 5 floor under the BKL would after that. So we start first with concrete work. On the original BQ, we can see it's very long and not classified. So for the improvement, we can classify it like in suspended slab, exceeding 100mm but not exceeding 150mm thick. And so for the reinforcement, they have fabric reinforcement and bar reinforcement. So for the fabric reinforcement, on the original BQ, it's very long description. So for the improvement, we can only stated the mesh, the width and the lap. So for the bar reinforcement, we can arrange it in order, and also we can add its function. For example, like 10mm as stirrup and 12mm as track and bend bar. So for this one, for the formwork, for the formwork, it's not stated the classification and the height. So for the formwork, we can state it like 2 feet of horizontal suspended slab and include the thickness, include the height. So that's all for BQ and improvisation.
So, for the specification of the documents, this project use the architect's specification or architect's guidelines for the specification, but it also have the same as the JKR standard specification, which is the JKR standard specification set out the requirements for materials, cements, aggregates, water admixtures, which is all must comply with Malaysian standards. It then specifies the workmanship, how concrete is mixed, placed, compact, and cured. So for slab, JKR requires that the concrete is designed to the specified grade. Formwork reinforcement are inspected and approved before casting. Concrete is placed in layers, compacted in vibrator to avoid honeycombing. So for this project, the upper floor slab is 150 mm thick and grade 30 concrete is using, and also high tensile steel bar. The architect also specified that the sockets that the underside must be fair and true, ready for the ceiling finish. So this project also use the architects, but it also align with the JK spec. So that's all.
My name is Muhammad Hamim bin Hamzah, and I want to explain reason for non-compliance with SMM2 standards and recommendation and solution for it. In construction, accuracy is everything. However, at ICC Pudu, speed was prioritized over precision. Because of the urgent need to relocate traders from Old Pudu Market for TRX development, the project team used the outdated SMM1 standard to rush the documentation process. This decision to skip modern SMM2 standard created a foundation for significant project failures. I will discuss the reason for non-compliance with the standard method of measurement 2 or SMM2 and its impact on project outcomes, followed by proposed recommendation and solution. Firstly, one of the main reasons for non-compliance with SMM2 is time constraint and rush work. In construction project with tight schedule, measurement processes are often hurried or partially skipped in order to meet deadline. This focus on speed rather than accuracy can lead to errors and omission. In our selected project, an older measurement standard, which is SMM1, was used to speed up documentation due to the urgent relocation of traders from the old Pudu market, which increased the risk of non-compliance. Another contributing factor is the failure to update to the latest edition of SMM. Some organizations continue using older standards because they are more familiar or easier to apply. However, this practice can result in inconsistencies with current measurement rules and classifications, especially when adequate training on updated standards is not provided. Non-compliance with SMM2 has significant impacts on project outcomes. Ineffective measurement leads to poor resource management, causing wastage of labor, materials, and time, which ultimately delays project completion. Financial losses may also occur, as delays can result in penalties such as liquidated asset damages (LAD) as seen in the ICC Pudu project. In addition, poor workmanship may arise when important items or materials are overlooked, affecting the building's functionality and increasing long-term maintenance requirement. Therefore, compliance with SMM2 is crucial, particularly for large public projects like ICC Pudu. Proper measurement ensures all building systems are clearly specified, reducing risk of defects, flooding issues, and operational failures. To address these issues, several solutions are proposed. These include the adoption of SMM2 compliant technology and software, the implementation of penalty and incentive systems, the use of structured guidelines and checklists, and continuous training and capacity building. Together, these measures can improve accuracy, accountability, and overall project performance. The ICC Pudu project proved that SMM2 is not just an administrative task, but is a vital risk management tool. By following this standard, we safeguard public funds and ensure that buildings are functional for the long term. Adhering to standard ensures we build with integrity, not just speed.
In conclusion, the Integrated Commercial Complex Pudu, or ICC Pudu, was designed to evaluate compliance of the BQ with standard methods of measurement 2, focusing on the reinforced concrete upper floor and roof slab. The findings show that the project primarily applied SMM1 instead of SMM2, resulting in less detailed measurement and several non-compliant issues. The main causes identified were time constraint, work pressure, and reliance on outdated standard. These issues led to inaccuracies in cost estimation, resource management, and construction quality, contributing to delays, liquidated messages, and post-completion problems. The improve of BQ prepared using SMM2 clearly demonstrates that the proper item description and measurement standards significantly enhance project planning, risk management, and overall performance. Therefore, strict compliance with SMM2 is essential for effective project delivery and long-term sustainability.